There we go. Okay, so we're going to be dealing with operations with polynomials, and I made this chart for you just to remember the laws of exponents, really. That you have the product of powers, meaning that if you have two things with the same base and different exponents, you just add their exponents. So I want you to write an example down at the bottom. X squared times x to the fourth power. Can everybody see that? X squared times x to the fourth power. Notice they have the same base of x. So if they do, you just add the exponents. So 4 plus 2 would be what? So you'd have x to the sixth power. So that's product of powers.
I have a question.
Yes.
You added the exponents. What about the two?
Right here? If you were just adding x plus x, then it would be 2x. But right here, we're not adding them, we're multiplying them. So therefore, it wouldn't be 2x. You would just keep the same base and add the exponents. So you're thinking of adding them, I think. And then here's some more examples to the side. You can also do it when you have a base of 3 or p or anything else. Alright, quotient of powers. So if you were dividing instead of multiplying, so let's just use the same one. So x to the fourth. Let me use x to the third. So if they're dividing and they have the same base, all you do is keep the same base, which is x, and then subtract the exponents. So 4 minus 3 would be what? Just 1. X to the first power, or just x. Okay, and you can do that with these. See, 9 to the fifth over 9 to the second power, you just subtract the exponents and be 9 to the third. Alright, negative exponents. So say if we had x raised to a negative power, you always, to make this a positive, you move it to the bottom. Okay, if it was a negative on the bottom, you'd move it to the top. So let me give you two examples. I'll write them out to the side. If we had x to the negative 2 power, go ahead and write that. We know there's no denominator, but if there's no denominator, we know it's a what on bottom? A 1, right? So if you want to write it like that, you can. So to change this to a positive exponent, which we always want, we just put this on bottom, and it becomes positive, and then put the 1 on top. If it was a negative exponent in the denominator, so 1 over x to the negative 3, then we would move it to the top to make it positive. So this would just be x to the third power. Any questions about those? Okay. Now let's look at power of a power. So if you're raising something to another power, so say if we had x squared to the third power. Go ahead and write that example. So if you're raising a power to a power, you multiply the exponents. So this would be x to the what power? Good. And a lot of people get product of powers and power of power confused. So see the difference. You're multiplying something by the same base, you add the exponents. If you're raising a power to a power, you multiply the exponents. Okay? So don't get those confused. Power of a product just means that if you had x squared y and everything in here was raised to the fourth power, then these two separate terms would also be raised to the fourth power separately. So x squared to the fourth power would be x to the what power? 8. And then y to the first power to the fourth power would be y to the what? Fourth. Good. So that's all that's saying, is when you square or have everything on the parentheses raised to a power, you distribute that power evenly. Alright, power of a quotient just means that if something's raised to the negative power, then you have to flip them just like we did up here. Nothing new there. And then 0 power means that anything raised to the 0 power is 1. And I want you to take your calculator. Okay, somebody give me a random number, any number. 3. Raise it to the 0 power on your calculator. The raising to power on the calculator looks like this. So type in 3, this button, and then 0. It's what? Good. Alright, what about negative 1/2 raised to the 0 power? Did you put it in parentheses? Try it again. What'd you get? 1. Good. Anything raised to the 0 power is going to be 1 except 0. See where it says x cannot be 0? Try to raise 0 to the 0 power. Tell me what you get.
Error.
Good. Can't be done.
So it's always just going to be 1.
Yes, unless it's 0. Then you can put undefined. Yes.
On the product of powers and powers of a power, is it just like if it's in parentheses, pretty much, you're like multiplying?
Yes. Alright, so these are kind of the laws. They're kind of reviewed from algebra, hopefully. And now we're going to do some problems using these laws in a minute. Okay? Alright, let's talk about a monomial. A monomial is a number, a variable, and expression that is the product of one or more variables with non-negative integer. Underline those two. Non-negative integer exponents. Non-negative means literally no negative numbers, right? So 1, 2, 3, 4. What is an integer? Do y'all remember?
It's like a negative or positive number.
Good. Negative or positive?
Whole number.
Whole number. Good. So integers are like -5, -4, 1, 2, 3. But when it says non-negative integers, somebody name me what those have to be.
Yeah, that has to be like a
They start at what? 0 and go 1, 2, 3, and so on.
The
So-
positive numbers instead.
Yeah. So basically to be a monomial, you have to have only non-negative integer exponents. No fractions, no negatives. Okay, and there also can be no power of power. Oh, sorry, this is when it's simplified. When it's simplified, meaning there's no powers of powers, so this is what I'm talking about. If you have this in your problem, it's not done yet, because you can simplify that, right? Each base appears only exactly once. So, for example, you couldn't have x squared plus 3x squared, because you can simplify that, right? All fractions are in simplest form, meaning don't leave 2 over 4. Put it as what? Good, and there's no negative exponents, so we can't leave x to the negative first power. We'd have to move that on bottom. So this is just saying a monomial is simplified when all of these are completed. And to be a monomial in the first place, you can't have non-negative integers. Alright, I know that was a lot, but I promise it's very easy once we get to applying it. Flip it over. Alright, so A, B, and C on the next page are kind of examples of what is a monomial, or excuse me, a polynomial, and what is not. To be a polynomial, you have to have non-negative integer exponents. So for this first one, do any of these terms have negative integer exponents? Are any of them fraction exponents? Good. So this is a polynomial. It already says it. You don't have to write it down. Because each term is a monomial, meaning again that there's no fractions or negatives for your exponents. And the degree is just going to be the highest exponent of each term. So what I mean by this is your degree is adding your exponents together. So the degree of this term is what? 7. Good. And the degree of this one is? And which one's greater? So the degree of this whole thing will be 7, because this is the bigger one. Does that make sense?
Yeah.
Okay. The next one is not a polynomial because square root of x is not a monomial. Can somebody tell me why the square root of x is not a monomial? Only conditions is it has to have positive exponents and whole numbers, right? Does anybody know what the exponent is of square root of x?
-1. And an I.
If I told you the square root of 4, this is the same thing as 4 raised to what power? Nobody knows? Alright, what is the square root of 4? Type in 4 to the 1/2 power in your calculator. Tell me what you get. The square root of something is the same thing as that number raised to the 1/2 power. So square root of x is the same thing as x raised to the what power? 1/2. And see how this is not an integer because it's a what? A fraction, right? So anytime you see a square root, it's not a polynomial because of the 1/2 power. Okay, next one. Can this one be a monomial or a polynomial?
No.
Because it has what?
Negative.
Negative exponents. Very good.
Can you repeat that?
Yeah, this cannot be a polynomial because of the negative exponents. Your exponents in all terms have to be positive and whole numbers. Sorry. Okay, so for 2a, let's look at this one. Any thoughts on whether this is a polynomial or not? Okay, why would you think it's not one?
Right.
Which one?
This one.
Yes.
Are we sure?
It has a whole number. And the denominator.
Okay, even though there's not any, it is a fraction. So, for example, what is the exponent of this x? Okay, what's the exponent of this y? It is -1. And the reason why is because, remember, if we had y to the -1, we'd have to write this as what? 1 over y. Good. So anytime a y is in the bottom, this really has an exponent of -1. So to be a monomial, or to not be a polynomial, you can't have square roots, you can't have negatives, and you can't have any letters on the bottom. So not a polynomial.
Wait. If the way to make y positive is to bring it to the bottom, right?
Mm-hmm.
But you just said if it's on the bottom, right?
Yeah, the reason it's on bottom is because it had a negative exponent. It doesn't right here. But to move it to the bottom, the reason it's on bottom is because it had a negative exponent.
Okay.
So again, when I ask you if it's a polynomial, just look for, is it a square root? Then it's not. If it's negative, it's not. If it has a letter on bottom, it's not. Alright, is this one a polynomial? Yes, okay. Because nothing is being square rooted. There's no letters on the bottom. And also these are all whole numbers, no fractions. Now we just have to find the degree. So what is the sum of these exponents? 6. This one's going to be, this one's going to be 2. So the highest one would be, good, the degree is 7. The circle thing? Yeah, that's fine. No, that's fine. Alright, we got 4 more examples. Just tell me yes or no. Yes, and what's the degree? Good, 2. Yes or no? Yes, what's the degree? Good. Stop me if you have a question. Yes or no? Why? Good. Letters on bottom. Yes or no? Because of the square root. Very good. Alright, I put this in here just to remind you if you didn't know, but I don't think we need to go over it. Y'all know what like terms are, correct? Has to have the same what? Variable and exponent. Good. We don't need to go over that. Do we need to go over how to fold? Yes? Okay, we can do that. Alright, go. There's an example of one, but we'll just do one on our own. Write x plus 1 and 2x minus 2. We'll do that. Alright, so fold stands for what? And when do you use fold? When you multiply 2 binomials. Good. And what makes something a binomial? It doesn't have to be x. What does binomial mean? 2 terms. Good. So how do we know this is a binomial? Because it has 2 terms. Alright, what are my first terms here? And 2x. Good. First term in each one. So x times 2x. What's my outside terms? Good. What's my inside terms? And last terms. 1 and what? Good. Oops, sorry. So what's x times 2x? Remember, we just went over this. These have the same base, right? You keep the 2, the exponents, you do what with? Good. So 2x squared. What's negative 2 times x? Good. 1 times 2x. 2x and 1 times negative 2. Good. Can we combine our like terms? What are our like terms? Good. So what's negative 2x plus 2x? So we'll have 2x squared minus 2. So everybody's good with foiling? We remember how to do that? Alright, flip it over. So the 1 through 12 we're going to do together. 1 through 8 I'm going to let you kind of work on your own / with somebody. Alright, number 1. Do all of these have the same base? So we keep that base and do what with the exponents? So 6 plus 2 plus 7. That's it. Oops, sorry. There we go. Okay. Alright, what do we do when we divide? Subtract the exponent. So this will be what? Good job. I told y'all this was easy. Alright, number 3. Yes.
Why are you subtracting?
Because when you divide, you just keep same base, subtract. So when you multiply, you add, divide, you subtract. What is 28? What's the final answer? X to the 28th power. Good. You multiply the exponents. Alright, on the next one, we're multiplying a bunch of things together. Let's start with the coefficients. And what are the coefficients? 2 and 3 and 1. Everybody see that? 2, 3, 1. So what's 2 times 3 times 1? Good. Now let's deal with the letters. So we have 2 A's that we have to add together, so we keep that base. And what's negative 2 plus 3? Good. So we don't have to put a 1 right there. We can just leave it as A. Tell me what the B would be.
2.
Yeah, just B squared. And we'd have C to the what? Alright, can we leave it like this? Good. How do we make that negative exponent positive? Good. And what do we put on the bottom? Good. C squared. And it'll be positive once you move it to the bottom. So 6AB squared all over C to the positive 2 now that we moved it to the bottom. Sorry, that's a 6. Looks kind of weird. Any questions about that one? Alright. The next one we have to subtract that exponent, so we'll have q to the what power? Negative 5, and we'll have r to the what? Just r, good. And how do we simplify it?
Would you put r over q?
Good. R over q to the 5th. Very good. Everybody good? Okay. Next one, tell me what the answer will be.
Negative 8A to the 4th power B squared.
A to the what power?
4. Oh. 5.
Good. And B what?
Squared.
Very good. Any questions? Because we have an A right here, so we keep the base, add the exponent. So 3 plus 2. Alright, yes, Jackson.
What's like number 7? You like distribute the exponent?
Yes. So let's rewrite this. This will be 6 to the 3rd power. When you distribute it to the letters, it's going to be g to the what?
8.
15. Good. If you're raising a power to a power, you got to multiply. And then h to the what? Very good. Alright. I don't want you to leave it as 6 to the 3rd power. So tell me what that number is going to be. No. 216. Good. So 216. What else can stay on top? What has to move to the bottom? Good. Everybody see how I got 216? Yeah, you just type 6 to the third power in your calculator, or it's the same thing as 6 times 6 times 6.
How come you distributed the subscript?
The what now?
6.
How come I distributed it? You mean the exponent?
Right.
Because you have to do each term separately. This is one term, this is one term, this is one term.
So, like, same thing on number 8.
Yes. So it'd be negative 2 to the third power, a to the what power? Yes.
Why is it that moving negative makes it positive?
To the bottom?
Yeah. If it's on the bottom, move it.
It has to do with taking the square root, and we'll get that into that on 5.3. Yes.
We don't have to. If it's above 30, then we don't have to do that.
If it's above 3.
Like, if
Important.
Yes.
Did Seth McMillan make it in?
Yes, he was finishing a test for Mr. Huggins.
Gotcha, thank you.
if like 6 to the third power, if it's higher than that, we don't have to be
Like if it's 8 to the third power? Or what do you mean? If it's 6 to the 15th
if
power?
the
Or?
power is higher, then we don't have to like make it like 6 times 6 times 6 times 6.
Anytime a number's raised to a power, I don't want you to leave it like this. I want you to tell me what it actually is.
Like for the first number?
Yes.
Oh, okay, now I know what you're saying.
Okay.
'Cause it's
Okie dokie. So that's a 3 on the outside, so tell me what to write.
negative.
Negative 2 to the, a to the, and on bottom, b to the, good. Alright, on this one, what's negative 2 to the third power? Negative 8, good. Negative 8, 8 to the 12th power over b to the 6th power. Very good. Any questions about that one? Everybody's good? Go ahead, Zach. The negative 8 part? Okay, the negative 2 cubed is the same thing as what?
Oh.
Negative 2 times negative 2 times negative 2. Okay. Alright, what's the next one going to be? Good. So when we subtract them, we'll get into the negative 8. We have to move it to the bottom, so our final answer will be what?
1 over n8.
Good job. Yes.
On number 10, do you treat it the same way as number 9?
You mean like the subtracting of the exponents?
Yeah.
Yes. But the 8 over 16 we treat as a fraction.
Right.
So how can we simplify 8 over 16?
1/2.
Yeah, it'd be 1/2. Like that. And then let's go ahead and put the letters on top, then we'll move any to the bottom that need it. So what's m to the third divided by m to the 7th? Good. And then what's n squared divided by n squared? And you'd have what?
0, so would you put 1?
What is 4 divided by 4?
1.
What's 3 divided by 3? What's x divided by x? What's n squared divided by n squared? Just 1. Good.
Oh, I thought.
So you don't have to put it.
Okay.
If you subtract them, it'd be into the 0 power, right? Anything raised to the 0
so
power is
either way.
1.
Is it 1 or like in the first?
What's 2 minus 2?
0.
So it'd be into the 0. Which is what? 1. Alright, so from here we have to move what to the bottom?
4.
So tell me what the final answer is.
It'll be 2 over
1. Good.
Oh.
Why did I move the what? Because it had a negative exponent. So I had to move it to the bottom to make it positive.
Just like move it up or down if it's no negative.
Correct. Yes, Abigail.
What if that wasn't like 1? Like,
If it was a 2 or a 4, you just leave it on top.
Okay, so you just had to bring that to the bottom. You don't have to change it.
Good. Yes. To the bottom? Because the 1 has an exponent of what? 1, right? So it's positive, so it doesn't have to move to the bottom.
So the only way, if you move it down, is the exponent is negative.
Yep. All right, number 11. Let's simplify the coefficients first. That's going to be what? Good. The A would be A to the what?
-5.
Good. And the B would be?
Here,
Good. What needs to move to the bottom?
the A,
Good. Not the 4? Negative 4?
no.
Good, because it has a positive exponent still, right? It's negative 4 to the what power? It's not there. 1. So this is negative 4, B to the 4th over A to the 5th. Alright, number 12 is kind of tricky. There's 2 ways you can do it. I'll tell you my way that I do it, that I think's easiest, and then I'll show you the other way and you can decide which one you want to do. Okay? What I like to do is, just like order of operations, if we had stuff in the parentheses, we'd want to take care of what's in the parentheses before we use the exponent, right?
Yeah.
Please excuse my dear Aunt Sally, P comes first, right? So let's go ahead and take care of what's on the inside of the parentheses, and then we'll worry about the negative 3 on the outside, okay? So the 5 stays the same, right? This will be A to the what power? What's negative 7 minus 1? Negative 8, good. And what is 2 minus negative 6?
Maybe 8.
Good. B to the 8th power, and let's leave that in parentheses.
Where you get negative 8?
When you divide, you have to do what with the exponents?
Subtract.
Good. So negative 7 minus 1
Oh.
will give us a negative 8. Everybody okay so far? All right, now let's distribute the negative 3 exponent to each term. So this would be 5 to the negative 3. When you distribute this exponent, you have to do what with them? Good, so negative 8 times negative 3 is going to give us what? A to the 24th. This would be B to the what?
Negative.
Very good. Now we just move the ones with negative exponents. Right here? When we subtracted the 2 minus negative 6, over here we had to keep, change. That's going to give you positive 8. Alright, so 5 to the 3rd we have to bring down, correct? What else? Good, and on top we'll have, okay, last thing we need to do is go ahead and cube that 5. That's going to be what? Good. So this is A to the 24th over 125 B to the 24th. Okay, I'm going to leave that up there and then I'm going to show you over here how to do it the other way, if you'd rather do that. Okay, the other thing you can do is distribute this negative 3 into all the terms before you simplify it. Okay, so this would be 5 to the negative 3. This, if you distribute the negative 3, would be A to the what? 20 what? 21, right? Negative 7 times negative 3, A to the 21, B to the what? Negative 6 over. And on bottom we'd have A to the negative 3, B to the 18th. And then you can simplify it that way. See what I mean? So you can either simplify it first, then raise it to the power, or raise it to the power, then simplify, whichever one.
Which one's shorter?
I mean, they'll probably take the same amount of time. So this one, you just have to move that one to the bottom. You would have to subtract these, so 21 minus negative 3. That's going to give you 24, right? And then this one would give you negative 6 minus 18, that's negative 24. You move that into the bottom. You do the same thing, just 2 different ways. Okay. Go ahead and work on 1 through 8 on your own. If you would like to work with somebody, you can. And that sheet that I passed out at the beginning, that's your homework for tonight, okay? That'll be checked tomorrow. Tomorrow's Friday.
I get the sheet.
Yeah. Oh, no. I didn't give it to you. And I'd like you to work out on the bottom of the sheet, okay? There you go. Let me know if you need help with these 1 through 6 problems.
Are you sure?